talking about? I'm talking about from A to B when we have, for instance, rate of change provided. Yes, rate of change, integrating rate of change, we just have the changes in function, the net change. That means this is called the net change. That's net change in the values. That means what was the change, what was the amount between A and B. Okay, because antiderivative of the derivative is just the function. Okay, that means now let's see. First of all, I think we have this previously when we were talking about fundamental theorem, but just in case we don't remember, we have to know how to calculate displacement and total distance traveled, because that's different. When we have velocity, we can always integrate and get the amount of the miles or kilometers or meters traveled by an object. If the velocity is positive, then we have no problem. We can just integrate velocity on the certain interval, and displacement and total distance will be the same, because if the velocity is positive, everything is happening in one direction. We will call positive direction. But what happened if the velocity is also negative? Yes, that means, let's say I just walked 4 steps forward and 4 steps backwards. Then my displacement is 0, but the total distance traveled, it's actually 8 steps. That means we have to find out what is the interval where the velocity is positive, then just integrate, and where it's negative, we will actually take the absolute value and we will count as a positive. That means that's for the total distance traveled. Displacement is fine, just simply integrating. Okay, that means I have this, and this is the formula. Total distance traveled, we can see, is just the absolute value. Everything must be positive, even if it's negative. Okay, I mean, I wanted to do this question. We will just do maybe 2 or 3 problems. Okay, we have we have the velocity of the particle, and we have to find the displacement and total distance traveled between 0 and 6. Okay, nice function to be integrated, no U substitution, just the power. But what we will do, okay, for the displacement, do we have to really think about positive, negative? Between 0 and 6, we can just integrate the velocity, and we will get the distance between 0 and 6. That's, I can even say distance between 0 and 6, because that's what we will do. The distance at 0, distance at 6, but at 0 is 0. The difference, that will be the displacement. I mean, that will be the displacement. The position at 0, position at 6, that's the displacement. Okay, and we can quickly do it. Or maybe I can leave it, because that's way too easy. 24t, correct? dt. Okay, that means you know what to do. You can get the antiderivative, substitute 6, substitute 0, and get the final meters. Okay, but let's do part B. Okay, total distance traveled between 0 and 6. What you will do, how you can find out where the velocity is positive, where it's negative? Because what we have to do, we have to just integrate absolute value. Yes, we can solve for 0. Yes, that's really good. Okay, that means I will come back to this. Velocity is equal to t cubed, because wherever is 0, I mean, it changes. That's the x-intercept changes the position from negative to positive. Okay, that means this is 0 if we can factor out t squared minus 10t plus 24, because we need a product form factored form. And who can help me to factor out the quadratic expression? T squared minus 10t plus 24. 4 and 6. 4 and 6. Oh, okay. Let's see 4 and 6. And you gave me two negatives because negative 4, negative 6, positive 24. Yes. Okay. That's we have 0, we have 4, and we have 6. Okay, 6 is the endpoint. But still, okay, that's time 0, 4, and 6. We still have to figure out where is positive, where is negative. Yeah, but we know it's like solving the inequality. We can use the test value. Actually, we know, okay, let's say 7, yeah, number greater than 6. I know that we're only looking between 0 and 6, but let's just do all of them. 7, when we substitute 7, this is the nice form. Yeah, this is still the velocity. 7, 7 minus 4, 7 minus 6, it will be positive. Let's substitute 5. 5 positive, 5 minus 4 positive, 5 minus 6 negative. That means multiplying one negative, it will be negative. And let's substitute 3. 3 minus 4 negative, 3 minus 6 negative. Negative times negative, positive. Okay, that means this will be the graph. Yeah, I don't know exactly, but positive, negative, positive. If we really have to, I don't know how high this is, but that's the, yes, positive, negative, positive. Okay, that we can integrate between 0 and 4 with no problem at all. Okay, and now what we have to do between 4 and 6, what we have to do with the formula? Between 4 and 6, we know that is absolute value, but yes, in order to rewrite, we will do this. We will just integrate with opposite sign of each term of this formula, okay? And I can probably leave it for you because you definitely know how to integrate this and how to integrate this. And then we will add together. Yeah, and this answer, this one will be when you will subtract. Right? I mean, without negative. Then you can check. Okay, but that's, yeah, please remember the displacement and total distance travel, the difference. Okay, we good with this. Okay, now let's see. Yes, I have a couple of solutions. Okay, this is too easy. Let me just okay, maybe number 4. It's also easy, but let's just do it because it's easier formula. Okay, just to get the idea. The water leaks from the tank at the rate 2 plus 5t liters per hour. And that's the, we can see velocity, rate of change, where t is the number of hours after 7 a.m. How much water is lost between 9 and 11? Between 9 and 11. That's what you will do to do this. If this is rate of change, I can even call it, oh, I have different color. And that's the rate of change. Then in order to find the amount, yes, we will integrate. And then we will find the amount of the water, let's call it S, between, okay, I don't want to put, because we have to know the time. If 7 a.m. is the beginning, then we can say corresponds to the 0. Then what about 9 a.m. and 11 a.m.? What is the corresponding time? Yeah, because we have to, it will be 2 hours, yes, between 2 and 4. Between 2 and 4. 4 and 2. Yeah, that's we can see between. Yeah, that's when we just need this. We don't need exactly how much water was lost at 4. I mean, at 11 a.m. or at 9 a.m., but we have to know between, because that's also the difference. Okay, and you can just integrate from 2 to 4, 2 plus 5t dt. Probably super easy integral. Okay, and that will be the answer. Okay, The answer is 34. I mean, it's 34. It's because it's leaking, then it's negative, but it's, yeah, it's 44, we can see. 34 liters. Okay. Oh, this one you can probably tell me the answer. Water flows into the empty bucket at the rate 1.5, just the constant, liters per second. How much water is in the bucket after 4 seconds? Of course, just 1.5 times 4. If you will integrate 1.5 dt between 4 seconds, you will also get 6. 6 liters. Okay. Yes, do we have time? Okay, let's do 2 problems. Shall we? Or maybe no, maybe. Okay, can that one be on the test? Oh, which one? This, the 6 liters? Could be. Actually, could be because what this question really does, if we think that's actually the, oh, okay. When we studying, yes, and we studying like complicated question, we applying the formulas. And then when we see question like this, really simple, then we forgot that we can just apply, let's say, common sense. Yeah, you will try think, oh my gosh, I don't know. Yeah, that means sometimes happens. We increase our knowledge and then we forgot how to apply the basics. That means, yes, it could be. Yes, let me make some notes. Could be as a nice relief of one question. Okay. Yes. Yes, yeah. Some, but you remember you're supposed to say fun, not hard. Okay, I promise it will be something similar. Okay, good. Yeah, I mean, it's still good, still integration. Okay, what I wanted to do, let's maybe, I wanted to solve this one, but I don't, if we will have time. But I also want to solve one of the written homework assignment, okay? That's mean, okay, let's try this one. Let's try this one, and then we can do, you can check the solutions later. But let's check this one. Because this one is interesting, yeah, how we can figure out. Figure below shows the derivative of the function f of x and the value of some areas. Okay, if f at 0, yeah, because f at 0 is 10, not always f at the initial value is 0. That means this one is 10. Sketch the graph of the function f of x. Give the coordinates of the local maxima and minima. Okay, that's we definitely see these zeros are the critical numbers, 2 and 5. Yes. Okay, but what we can do, we can start with this. What about the integral between 0 and 2 dx? And this is actually f of 2, f of 0. Because we would like to find the value at 2, the value for the maxima minima. Let's see, what is, we have the value at 0. Value at 0 is 10. Okay, can you tell me what is this integral between 0 and 2? It is 14, of course. That means 14 equals to f of 2 minus 10, because f of 0 was 10. What is f of 2? And we will repeat the process. F of 2 is, yes, 24. Oh, could be the maximum. We don't know. Okay, now let's keep working on the next area. The integral between 2 and 5, you can tell me, and this is value at 5 minus value at 2 of the antiderivative. What is the integral? Now, please be careful. What's the integral between 2 and 5 of? Yes, it's negative 20. Okay, f of 5 minus 24, because f of 2 is 24. Please tell me what is f of 5. F of 5 will be 4, because we will add 24. Okay, yes. And the last one, integral between 5 and 6. It's equal to the difference between f of 6, f of 5. And then what is the integral? Now everybody knows. And can you tell me value at 6? Value at 6 is actually 16, not 8, 16. Okay, that means now I think we are ready to sketch the graph. This is the derivative, and this will be a function. Okay, f at 0 is 10. Yes, we know 10. Now, at 2, at 2 is 24. That means let's say 2, 24. And what about 5? At 5 is, it's back to the 4. That means let's say this one is 5, 4. And at 6, it's a little bit higher, 16. 6, 16. Okay, that means this one is maximum and this will be minimum. Minimum value is 4, maximum value is 24. Okay, really nice use of this. Okay, and let's do one more, even if we stay a little bit longer. That's the same. This one you can do it. Oh, this one. Okay, let's try this exercise. Okay, that's mean what we have. We have to be, yes, we have to be careful. I was looking at my, okay, yes, okay. That's what, yeah, this, you probably recognize this question. That's what we have. We have like the firm keeps track of the total money spent on Tesla stock by their clients each day of the week. T of T is the total money spent. Okay, because I don't know, I'm reading. Total money spent is T of T. And the function that is total money spent is defined, is expressed as a number, yes, number of stocks, N of T, times the price, P of T. Yes, price times the number, where N of T is the number of stocks bought that day, and P of T is the price of the Tesla stock that day. It's the number and price, of course, total money spent. Suppose that the price of a Tesla stock on a day T equals to 0, like initial, it's $700, and the number of stocks bought is 200. And the graph of the rate of change of this is presented here. Yes, that means for the price, we have the graph. For a graph of this, I mean the rate of change, because this is P prime. And we may notice in part B, N prime, the rate of change of the number is actually given by the formula. And that means this one is graph, this one is formula. Okay, we have to deal with both. Part A is asking, what is the price of a Tesla stock at the end of the day 7? Right? That's what that's now, because this is sometimes confusing, we have to include everything. Yes, the price between 0 and 7, and also adding that value, that price at 0. Let's see. For part A, in order to, I can maybe write here, in order to get the price, and we only have the rate of change, we will integrate the rate of change, correct? Between 0 and 7. But this one is between, this will give us the, price. Yes, this will give us the price between 0 and 7. We still have to add the price at 0 because it's at the end. That means it's a total. Okay, it's a total. Because this one will be the price at 7 minus the price at 0. And we have to do everything. That means, please tell me, what is the integral? What is the integral of the P prime between 0 and 7? We have the graph. Can we figure out on the graph? It's the area between 0 and 7. Of course, the net area. If something is negative below the x-axis, it will be negative. Okay, that's mean, can you try to help me to count this? This is 1. This will be 2 of those. Maybe, actually, let's maybe, I can say, okay, that's mean this one is -1. This one is -half, -half. This one is +1/2. This one is +1, +1, +half, and -half. That's maybe the easiest. That's we have negative, negative. 1, that's gone. +1/2. I think it's 1/2. Just actually, the scales, yes, because I did this. Okay. Yeah, if you have to leave, you can leave, but I will finish this question, okay? I will finish this question. The scale, we have to be really careful. Of course, 1, 2, 3, 4, 5. X's, they go by 1, and Y's, they go by 2. Okay, I know, and look, they look like a square. That's mean what we have. This area is -2, -1, -1. And the same, yes, negative, +2, +2, 1, 1, -1. Okay. So now let's maybe cancel out negative, positive, this and this. Okay, 1. Right, that means this is 1. P at 7, the price at 7, and then this one was 700. That's mean what is the price at the end, exactly at 7, at yes, $701. Okay, okay, good. That's we have the answer A. Now we have to do exactly the same. How much for part B? How much Tesla stock did the clients buy on the day 7? And that's we have to do exactly the same, but we don't have the graph, we have the formula. It means part B, we will integrate between 0 and 7 the rate of change. And this will be n at 7 minus n at 0. Okay, and we're looking for, let me actually solve it. We're looking for the number at 7, at the end of the 7, total, everything, which we have to do between 0 and 7. That will be the amount, and plus the number at 0. What was the number at 0? Exactly at 0. Do we remember from, was 200, yes? That's when because what is my main point? My main point is when we calculating that amount between, like, let's say 0 and 7, between some time interval, we just integrating. But when we have to know the total, yes, the total, we always have to add the initial values. Okay, that means that was 200. Okay, that's mean now, who can help me to integrate? And do I remember the function? Pi sine of pi t over 7 plus 1. Okay, that means you really have to help me. dt plus. Okay. Okay, what pi, I can copy pi, constant. What is the integral of sine? What's the integral of sine? Integral of sine is negative cosine of the same angle. Okay, and now do we remember what we can do with this quantity? Pi over 7, the coefficient of the variable. Yesterday, you remember, sine of ax. We will say negative cosine of ax, and how that a is affecting the antiderivative? This is just the formula. We will divide by a, 1 over a. That means in our situation, the a is pi over 7. We will divide by pi over 7, means multiplying by 7 over pi. And then integral of 1 is t, from 0 to 7. And plus 200. Okay, that means the integration is important. And this. Okay, let's do it. I can erase this. Do you know the answer? We can cancel out pi and let me substitute. Negative cosine, when we substitute 7, it will be 7 over 7, just pi. Okay. Or actually 7, because this is 7. And then plus 7 minus, when we substitute 0, it will be 0 plus 0. Okay, I think I set up the fundamental theorem correctly. Okay, what is cosine? Okay, yes, Laura Jean, it is 21. Okay, cosine at pi, we know it's -1 times -7, +7, +7. Oh, and I'm missing 7. So my negative and negative is positive. Yes, it is 21. I mean 221. Thank you. Okay. That's the number of stocks bought, 221. Really nice, yes, but we can see. And now the last part is the total money spent on Tesla stock increasing or decreasing? Again, on the day 7. By how much? That's what the question is asking. Maybe you can help me, because I think I know what to do, but if you can tell me what to do, I can do it. Total money. Do we have the formula? Yes. Do we have the formula for the total money? We have the formula for the total money. And now, if we have the formula for the function, how we can check if the function is increasing or decreasing? Yes. What rule we can use? I mean, we can check if the derivative is positive or negative. Yes, let's do it. That means part C. Total money spent is a number. Yes, that's really good. Okay, I will write down number times the price. That means we need the derivative. Derivative of n times this product rule. Number times derivative of the price. And now we can do everything at 7. Please tell me all of these numbers. Number at 7 day derivative. Okay, yes, that's me. Let's do it. And we can check if it's positive or negative. If it's positive at 7, it's increasing. Okay, n prime. Oh, you're giving me, okay, that means n prime at 7, it's 1. We will figure out, oh, p prime at 7 is -2. I'm just copying, but let's confirm if we okay with this. P at 7 is 701, and n at 7 we did calculate 221. Okay. Are we okay with 1? Where the 1 come from? We just have to substitute 7 to this formula. Pi sine pi over 7 times 7 plus 1. And this will be pi, 0, sine at 0 is 0, it is 1. And what about -2? Where the -2 come from? P prime at 7, from the graph. P prime at 7 is that value, and actually, yes, it's -2, because we can see it's not, yes, it's not -1. Okay, that's you good. And what is the number? It's 701 minus 442. Okay, 259, and we can say dollars per day, because this is rate of change. That means it's positive, it's increasing. But now they also asking, no, they not maybe asking, please tell me, because the total depends on the number and the price, yeah, number of stocks and the price. Was price increasing at day 7 or decreasing? That means P prime actually, can you see this? P prime was actually negative at 7. That means the price was decreasing, just in case if we decreasing, yes? And what about number? Was number increasing or decreasing at 7? Derivative was actually positive. That means was increasing, yes? Okay. That's how we can say the number was increasing, the price was decreasing because it's negative too, but it ended up the total of the money was actually increasing. Yeah, interesting. Depends on the data, depends on the situation. Even if the price was decreasing, the number was increasing and the final output is increasing. Okay, I just wanted to solve this question. Okay, that's mean please go. I will update every single solution. I will even look now for section 5.6 and 5.7 and 8. And please go through, open the blank presentation and try to solve every single question. That will be excellent practice and excellent actually practice before final or before the Thanksgiving. And please enjoy the next week. Please enjoy your Thanksgiving break. Okay? I want everybody to have an excellent family and excellent relaxing time. Yes, thank you. And don't forget to say thank you, to be thankful. I mean, we have to be thankful every day, not just next week. I don't mean really now, or even now it's nice, but no, just to everybody who will see, who will meet, who will know, who you know actually. Okay. No, not only next week. I think I said we have to be thankful every day. Okay, enjoy enjoy your break next week, and I will see you after the break. Thank you, and yes, thank you, and see you later.